We all absolutely love that instant acceleration and the super quiet ride of an EV, but there's something lurking in there, a system that's incredibly power hungry and has a massive impact not just on your driving range, but on the planet too. So today, we're going to dive into the really surprising science of your car's air conditioning.
All right, quick question for you. In a modern electric car, you've got these giant screens, you've got amazing sound systems, heated seats, heated steering wheels. But after the electric motor itself, what do you think is the single biggest drain on your battery? You guessed it, it's the air conditioning. Yep. On a hot day, just keeping the cabin comfortable can literally slash your driving range. And that makes AC performance a really, really critical piece of the whole EV puzzle. But believe me, the story does not stop with your battery.
Right, so the true climate cost of staying cool, it isn't just about the energy your car is using. The actual chemicals that make it all possible, the refrigerants, well, they have their own powerful and, let's be honest, often really problematic impact on the environment. And to see why, we need to understand one key metric. And that metric is global warming potential, or GWP. Now, it's a pretty simple idea. Basically, it compares how much heat any given gas can trap versus the same amount of carbon dioxide. So CO2 is our baseline. It has a GWP of 1. A gas with a GWP of 100 is, you guessed it, 100 times more potent as a greenhouse gas. And when you see the numbers for refrigerants, that's pretty eye-opening.
Okay, just look at this. The GWP for the old standard refrigerant, a chemical called R134A, its GWP is over 1400. That means it is 1400 times more potent than CO2 at trapping heat in our atmosphere. Faced with a number that's staggering, the industry knew it had to do something. But, as they found out pretty quick, even the new solutions came with their own hidden catch.
So, the leading alternative that they came up with, a refrigerant called R1234YF, it did dramatically lower that GWP number. But, and this is a big but, it introduced a whole new problem. It belongs to a group of substances called PFOAS, which you've probably heard of. They're now infamous as forever chemicals, and they're facing more and more pressure for one simple reason. They just don't break down in the environment. Ever.
And this isn't some distant, far-off threat. The European Union is already taking major steps to ban thousands of these PFAS substances. That puts automakers in a really tough spot. All of a sudden, they need a refrigerant that's not only low GWP, but also completely PFAS-free. And that search is what led to a whole new generation of technology.
And this brings us to the solution, a truly game-changing electric scroll compressor. It was developed by a company called Guchen Industry, and it's designed from the ground up to tackle both problems at once, the energy drain and the chemical pollution.
So here it is, the GC34B800P. Now, it's built for these modern 800-volt EV systems, which means faster, more efficient power management. It's also incredibly light, just over 6 kilograms, which, every little bit helps with overall vehicle efficiency. But its most important feature is the refrigerant it's designed to use.
Its secret is refrigerant-grade propane. It's also known as R290. And yes, you heard me right. Propane, the same stuff that's probably in your backyard grill, is now at the very heart of cutting-edge EV technology. And as it turns out, it's a brilliantly simple and incredibly effective solution.
So what makes R290 such a huge leap forward? Well, it offers this amazing combination of benefits that make it an almost perfect choice for the future of electric cars.
First off, its global warming potential. Remember that old refrigerant with a GWP of over 1400? The GWP for propane is just 3. 3! That is an absolutely incredible drop. It makes it one of the most climate-friendly options on the entire planet.
Okay, so here's the side-by-side comparison that automakers are looking at right now. You've got the current option, R1234YF, a low GWP of 4, but it's a PFS forever chemical. Or you've got propane, an even lower GWP of 3, and it's completely PFS-free. It just neatly sidesteps that entire regulatory minefield. The choice seems pretty clear, right?
But okay, does this greener choice mean you have to sacrifice performance? Absolutely not. Look at this. At 6,000 RPM, this little compressor is pumping out over 6,700 watts of cooling power. And that third column, COP, that's the key. It stands for coefficient of performance, which is basically just a fancy way of saying how efficient it is. These numbers are fantastic. It means less energy is being pulled from the battery, which directly translates to more driving range for you. So what does this all mean for the bigger picture?
I mean, this choice isn't just some small technical detail buried in an engineering diagram. It's really about future-proofing the entire vehicle, for the car maker, for you as the driver, and for the planet.
This choice really creates a perfect trifecta. 1. Its ultra-low GWP means it meets the strictest climate regulations on the books. 2. Being totally PFAS-free, it avoids a whole future of regulatory headaches and bans. And 3. Its high efficiency helps extend that driving range, which is the #1 thing every single EV owner cares about. It's a true win-win-win.
You know, we often think of green technology as these massive solar farms or some revolutionary battery breakthrough. But as we've seen, sometimes the most impactful innovations are these smart, elegant solutions to problems we didn't even really know we had. It just proves that the future of driving isn't just about how we go, but also about how we stay cool along the way.